Every day, we take part in the Earth's climate story. In the Bay Area, that story is being written in hotter summers and longer fire seasons. And that's actually true for much of our state. But climate change isn't just happening to us, it's shaped by the ways we live on our planet. In this video, we'll cover evidence of climate change beyond natural variation, as well as greenhouse gases and our role as humans in producing them, also known as human forcing. We'll talk about patterns of climate change and then finish with environmental justice. The evidence for a warming planet is overwhelming and consistent across multiple lines of measurement, both of temperature itself and its effects. First, global temperature anomalies, or the difference in annual temperature from the multi-year average, show a clear upward trend since the late 19th century. The world is warming. Second, Arctic sea ice is declining, a direct response to that warming. And we can see in this graph two measures. In black is sea ice change in March, and then in red, even worse, is the change in September. And this suggests that summer melt is occurring later into the year. And third, sea level is rising, both from the melting land ice and from the ocean itself expanding as it warms. So together, these data sets tell a clear story. The climate system is changing. But you might be thinking at this point, we just spent a video talking about natural controls of the climate. So why is this different? Climate tells us about patterns and includes natural variation, but these natural controls don't explain this global upward trend in temperature. Rather, the scientific consensus, meaning overwhelming agreement among climate scientists, is that the main driver behind this warming is the rapid rise of greenhouse gases in the atmosphere, especially carbon dioxide. One way we monitor the amount of CO2 in the atmosphere is by taking measurements at the Mauna Loa Observatory in Hawaii. These measurements are taken high up in the atmosphere where a lot of mixing occurs, so it gets a good sense of global CO2. The data collected at Mauna Loa shows CO2 climbing steadily since measurements began in the 1950s. And we can see by zooming in that natural variations are present. The red line is squiggly because it varies by month, but overall, the amount of CO2 in the atmosphere is steadily increasing. And this upward trend is the direct result of human activity, mostly from burning fossil fuels. This is what climate scientists call human forcing. When human activities add greenhouse gases to the atmosphere, they trap more heat, changing the balance of energy flowing in from the sun and then out to space. In other words, we're tipping the energy budget of the Earth system. This tipping of the Earth's energy balance is directly tied to the carbon cycle. We've already talked about this cycle a little bit, how carbon moves between the spheres, and for a long time the carbon cycle was basically in balance, with a lot of carbon being stored underground. But when we burn fossil fuels, we're pulling carbon out of the ground and releasing it into the atmosphere much faster than natural processes can absorb it. You can see this phenomena in the CO2 record from Mauna Loa Observatory. The steady rise over time isn't a coincidence. It reflects how our energy system has worked since the 19th century. And globally, fossil fuels account for about 68% of all greenhouse gas emissions and 90% of CO2 emissions, according to the United Nations. And that's key. This isn't just about a bunch of individuals making bad choices. Emissions are baked into how we produce energy, move around, build cities, and run industries. In other words, the warming we're experiencing isn't an accident. It's a structural outcome of how our society is organized around fossil fuels. These emissions come from every part of modern life. Energy generation is the largest single source, followed by industrial sources like manufacturing, then agriculture and farming, transportation, and a little bit from our buildings like heating. And we can see how each category, except for buildings, is trending upward at varying rates. And this is important. Greenhouse gases aren't just an environmental issue. Again, they're tied to the way our societies are built and powered. We've talked a bit about feedback loops before, but it bears repeating at this point. Warming doesn't just happen in a straight line. It triggers cycles of compounding effects, building off of the warming that other effects create. So we've seen the ice albedo effect. When atmospheric temperatures rise, sea ice melts, and the Earth reflects less sunlight, which leads to more warming. This also feeds into other effects. For example, warmer air holds more water vapor, and water vapor itself is a greenhouse gas, trapping more heat in the atmosphere, like CO2 does. And feedbacks can also be human-driven. More frequent heat waves, for example, increase the use of air conditioning, which can lead to more energy use and more emissions because most of us in the US still get our power from fossil fuels, about 60% of US energy from sources like coal and natural gas. Feedbacks make climate change both more complex and more urgent because of the risks of a tipping point where climate spirals out of control. But warming isn't the same everywhere. Global climate change is uneven. This map of temperature anomalies shows strong warming in many regions, but also pockets of weaker warming, or even cooling, what we call warming holes. That's because the climate system is expressed through regional interactions, like we discussed in our last video. So circulation patterns, ocean currents, topography all affect the texture of climate change. So climate change is global, but its effects are experienced locally. Here in San Bruno, the pattern is clear. Average temperatures have been rising over the last half century, with a couple dips here and there due to local weather variations. What we're seeing globally is happening right here at home. And in inland parts of the state with less temperature moderation from the ocean, like Sacramento, the trend is even more pronounced. So even just 100 miles apart, we can see a difference in warming. In this case, it is increased. And that warming isn't just an abstract number, of course. It shows up in how we experience the weather. So, for example, heat waves are happening more often. This first graph shows the number of heat waves per year in urban California since the late 50s, rising quite sharply. And these heat waves are lasting longer per the second graph and getting hotter per the third. So this trend is one of the clearest fingerprints of climate change in our state. And one of the major downstream impacts in California is fire. So as temperatures rise and landscapes dry, fire seasons are getting longer and more intense. So for example, our state fire agency, CAL FIRE, reports the number of acres burned each year. And when graphed out, we can see that the count is climbing. So if you've been feeling like fire season has been getting worse and worse in California, you are not alone. But climate change doesn't affect everyone equally. Exposure to environmental harm among individuals is also unevenly distributed. Some people are more exposed or have fewer resources to respond to these harms. So, for example, outdoor laborers, unhoused people, and elders are especially vulnerable to extreme heat and to wildfire smoke. And in terms of wildfires themselves, not everyone can evacuate or rebuild as easily. So this isn't just about the atmosphere, it's about our social systems. And when infrastructures like housing, cooling, or healthcare are unequal, the risks of climate change are unequal too. When we talk about responding to climate change, one key idea is resilience. Resilience means the ability of communities and systems to withstand shocks, like extreme heat or wildfire smoke, and then to recover from them. But resilience is, of course, not just environmental. It depends on the infrastructures we build, things like housing and healthcare. And because access to those resources is uneven, then resilience is also uneven. So if climate impacts are unequal, then our responses have to address those inequalities. And this means thinking beyond just cleaner energy. It's about designing infrastructures like energy, housing, labor protections, so that adaptation isn't a privilege. And it's also about our social infrastructures, the networks of care and public health systems that help keep communities safe. So the choices we make about how we build, care for, and protect one another in the face of climate change shape how our societies interact with the planet itself. And this interaction is unavoidable because we're not outside the Earth system, we are a part of it. Next week, we will begin our second project for this course. We'll be putting together story maps detailing the impacts of climate change in a location of your choosing, pairing pictures, text, article links, and map pins. That will be posted on Canvas by Sunday. Thank you for watching, and see you later.